Have you ever wondered how aircraft glide slope control systems work their magic to keep airplanes perfectly level during those crucial moments before landing? Today, we are about to demystify the science and technology behind this vital aspect of aviation. But before we start, please consider liking and subscribing to our channel. Your support keeps us going. Now, back to the topic. What's the glide slope anyway? How do glide slope control systems work? It is essential to understand what the glide slope is. In aviation, the glide slope is a precise and predefined path that an aircraft follows when descending toward a runway for landing. It is like a virtual highway in the sky that helps guide the aircraft safely to the touchdown point on the runway. Picture a glide slope as an inclined plane that starts at a certain altitude and descends gradually until it intersects with the runway. This path ensures a safe descent angle, allowing the aircraft to approach the runway at the right speed and angle for a smooth landing. Maintaining this glide slope is so important for safe and efficient landings, especially during low visibility conditions or at busy airports. The basics of glide slope control systems. Glide slope control systems are the technical wizardry that enables an aircraft to stay on this imaginary glide slope highway as it comes in for a landing. These systems involve various components, from ground-based equipment to onboard avionics and flight control systems. Let us take a closer look at how they all work together to keep the aircraft on track. At airports, ground-based radio transmitters guide the aircraft during their final approach and landing. They emit signals for aligning with the runway centerline or localizer signal and ensuring a correct descent on the glide slope, forming the Instrument Landing System or ILS. The ILS combines radio signals and visual aids for precise guidance. Aircraft avionics systems, like the radio altimeter, provide accurate altitude measurements, and autopilot systems, acting as expert co-pilots, make rapid adjustments to the plane's pitch and heading to maintain the path going down. The flight control systems, featuring control surfaces such as ailerons, elevators, rudders, and power controls such as throttle, thrust levers, ensures the aircraft remains on the desired glide slope for a safe landing. Akin to a carefully choreographed performance essential for maintaining the ideal descent path. The glide slope control process. Imagine you are the pilot, with one primary objective, a smooth and perfectly aligned landing on the runway. It all begins with establishing communication as you tune your aircraft's radio to the precise frequency for the Instrument Landing System or ILS, which includes localizer and glide slope signals. This ensures your avionics systems receives the important guidance signals required for a precise landing. The next step involves gracefully intercepting the glide slope, which entails descending from your current altitude to meet the glide slope's entry point. Typically, well before the final approach fix, your trusty flight director and autopilot come into play here, guiding you with appropriate descent rates and heading adjustments. Once you have harmoniously aligned with the glide slope, your avionics system takes over, continuously receiving the glide slope a signal and ensuring your current altitude matches the desired glide slope altitude. If you happen to find yourself above the glide slope, the system will instruct you to descend by displaying guidance on the flight director. Conversely, if you are below, it will prompt you to climb. Maintaining the glide slope involves making precise adjustments, particularly to the aircraft's pitch and power settings. For instance, if you are slightly too high on the glide slope, you'll reduce power and gently lower the nose to descend gracefully back on course. Conversely, if you are too low, increasing power and gently raising the nose allows you to ascend back towards the glide slope. Throughout this meticulous process, you'll keep a watchful eye on the radio altimeter, providing you with accurate altitude information above the ground. This is a very important tool during the approach and landing phase, ensuring you maintain a safe distance from the ground and the awaiting runway. Despite the incredible precision of the glide slope control systems, visual cues from the runway and its surroundings remain essential. This visual cross-check helps confirm your altitude and alignment. Elements like the runway threshold, approach lights, and various markers act as additional guides, reaffirming that you are precisely on the correct path. As you approach the closing stages of the landing, you will reach a pivotal moment known as the decision height or the edge. At This predetermined altitude above the runway, you must assess conditions and your visual contact with the runway. If all aligns perfectly, you will confidently continue the approach and proceed with the landing. However, if conditions aren't ideal, you will initiate a misapproach procedure, climbing away from the runway to prepare for another attempt. Assuming all unfolds seamlessly and you decide to proceed, you will maintain faithful alignment with the glide slope right down to the runway. With precision, the aircraft's wheels gracefully touch down on the runway surface, and you commence on the landing rollout, marking the successful culmination of your journey. What challenges do pilots encounter when managing the glide slope during an approach? While glide slope control systems are highly effective, they come with challenges. Weather conditions like low visibility can necessitate heavy reliance on the Instrument Landing System or ILS. Radio interference and mechanical failures must be managed. Human factors and the need for quick go-around procedures add complexity. Furthermore, unique terrain near airports can impact glide slopes. Despite these challenges, glide slope control is pivotal for safe and efficient air travel. It offers standardized and reliable approaches, reduces pilot workload, improves visibility in adverse conditions, increases airport capacity, and provides operational flexibility. In this video, it is essential to understand the differences between human and autopilot control. While advanced autopilots assist in maintaining the glide slope, human pilots bring adaptability and decision-making skills. In many commercial flights, both human and autopilot controls work together to ensure safety and precision. How does human control impact glide slope management during an approach with various methods and tech aids? Human and autopilot systems each contribute to ensuring safe landings in their distinct ways. Pilots rely on visual cues, instruments, and their experience to make critical decisions during landings, manually adjusting the aircraft settings to stay on course. They showcase adaptability in managing unforeseen challenges and responding to wind gusts or air traffic. Meanwhile, autopilot systems provide precise maintenance of the glide slope, ensuring consistent and smooth landings, reducing the pilot's workload by handling manual tasks and allowing them to focus on system monitoring and decision-making. Although autopilots have limitations in extreme conditions, pilots remain vigilant, overseeing autopilot performance and taking control if necessary. In many commercial flights, a combination of human and autopilot control during the final approach phase ensures a safe landing, where the autopilot maintains the glide slope while the pilot monitors critical factors, guaranteeing precision despite variations in visibility, runway conditions, and air traffic. The future of glide slope control. Glide slope control systems are rapidly advancing, integrating high-tech navigation like GPS for even more precise landings and boosting safety with sophisticated autopilot systems adept at handling complex flight scenarios. The potential for reduced human intervention looms ahead, as fully autonomous aircraft and UAVs are on the horizon, potentially transforming how we manage glide slope control. Safety measures are a top priority, driving ongoing efforts to enhance system redundancy and fault tolerance for smoother operations. Additionally, innovative weather-adaptive systems are in development, promising better adaptability in challenging conditions like strong winds or turbulence during landings. Moreover, there is a growing emphasis on optimizing glide slope control for energy efficiency, aligning with aviation's commitment to reduce fuel consumption and emissions for a more sustainable future. Glide slope control systems serve as the backbone of safe aircraft landings worldwide, providing a dependable path for planes to touch down safely. Whether under the guidance of skilled pilots or advanced autopilot systems, these solutions have evolved, embracing technology and automation for safer air travel. Despite their effectiveness, they do present challenges, underscoring the continued importance of human pilots in decision-making during landings. Looking ahead, advancement in navigation, increased automation, and improved weather adaptability promise even more precision and sustainability in glide slope control for the aviation industry. As we wrap up this exploration of aircraft glide slope control systems, we hope you have gained a deeper understanding of the precision and technology that goes into ensuring safe landings. If you found this journey through aviation intriguing, Don't forget to like and subscribe to our channel for more captivating insights. Your support fuels our passion for knowledge sharing. Until next time.